Hello, welcome to another session of machine learning with Python. And in this session, we'll create an artificial neural network using KERAS and Python. And first of all, I have downloaded a dataset in a CSV file. So let's examine the dataset. It's about diabetics, and we have several medical details in column 1, 2, 3, 4, 5, 6, 7 and 8, and the last column is whether that patient has diabetics or not. So this is the data set. So if you look at this data set, first is number of times pregnant and second is plasma glucose concentration. Next one is the diastolic blood pressure. Next is the skin fold thickness. Next 2-hour serum insulin, and next body mass index, and 7 diabetics predictory function, and the final is the age. And after these 8 features, you have whether it's the patient has diabetics or not. And then we'll go to our neural network, which I have already prepared. So we do the necessary imports from NumPy, import load text, sequential and dense, and we are using TensorFlow backend. So we are now loading the dataset load text, and we load the data file. We have the name of the file here. It should be in the same, we have put it in the same folder. And next we define the KERAS model. So we use sequential, model equals sequential, and next we add the layers. So here this statement which is highlighted, it does two things. So it handles the input layer, input dimension equals 8, input time equals 8, and also it has details about the first hidden layer. It has 12 neurons. So it does two things, the input layer and the first hidden layer. So input layer has 8 neurons, first hidden layer has 12 neurons, and next, and here we use rectified linear unit as the activation function. In the next layer also 8 neurons, activation function ReLU, and the final layer we need to get the we are getting the binary classification. So we use the activation function as sigmoid, and the neurons only one. Next we compile the KERAS model. So to calculate the loss, we use binary cross entropy. You can see the documentation about it, and the optimizer, stochastic gradient descent, and the evaluation matrix accuracy. So next we fit the KERAS model on the dataset, model fit xy, and we set the epochs as 150 and batch size to 10. So one epoch is the one full cycle of the dataset is trained, and inside epoch there can be several batches. So you can see the accuracy, sometimes it comes as 75, and loss. And finally we evaluate the KERAS model, model.evaluate, and we get it as 75.65. So when you are loading the dataset, the first 8 columns feature X, and the Y is the result, Y. So if you run all these things, you can see epochs, you get the output like this. It goes on till 150. And next we have the accuracy 75.78. So if we run it multiple times, you can see various. Right, that's the end of the session. Thank you very much. If you need the detailed explanation about this, you can go to the YouTube channel here and select this for the detailed explanation. Thank you very much.